Let's say you're a materials scientist. You're part of a team that is hunting for a new superconductor, a material that is easy to synthesize, easy to stabilize, and can be used to carry current without resistance or enable next-generation electronics. Easier said than done. The hunt for such a structure, or in this case, crystal, can take weeks or months, not just in the lab, but in the literature. Every lead begins with a paper, and every paper references another. You find yourself combing through thousands of entries across databases and journals, trying to piece together which compounds have been tried, which ones worked, and which ones didn't. It's slow, repetitive detective work, scanning titles, abstracts, and datasets for clues about superconductivity. Now, you might be saying, aren't there plenty of crystal databases you could search through? And yes, there are. Many of them that contain hundreds of thousands of records. But they're not categorized or annotated with the kind of information you need. Each crystal in the database is typically profiled with atomic coordinates and space group labels and maybe a little chemical metadata, but not much else. If you want to know whether any of the items are superconductors, you'll need to go through all of them and figure that out for yourself the hard way. But what if there was a better way? A way to transform existing crystal databases into knowledge bases that are actually useful for you in this quest. A way to enrich the records with language and meaning, with text that describes physical properties and tags that classify them as superconductors or semiconductors. How would you go about building such a system? How would you develop software that could transform an existing database into something like that? That's what today's paper is all about. In it, the authors introduce CLASP, Contrastive Language Structure Pre-training, a system that learns to connect crystal structures with the words used to describe them in the scientific literature. If you're already a member of Journal Club, you just got access to this episode. Log in and watch it anytime. See you there.